Hi and welcome to the Magic of Mathematics with Mrs. Arnold Harsley. Today we're looking at Algebra Part 6, Factorising Algebraic Expressions. In particular, what is factorising? We will refresh factors and highest common factors, and then we'll factorise some expressions. So what is factorising? So in Algebra Part 5, I showed you how to expand an expression, which means to remove the brackets. So I'll just quickly go through this example. We've got 3 bracket x, add 5. So what you do is you use the distributive law and you multiply the 3 with the x first of all to give you 3x. And then you multiply the 3 with the positive 5. 3 times 5 is 15 to give you 3x, add 15. Factorising is the opposite of expanding. It means to take an expression like 3x plus 15 and put the brackets back in. So just a quick refresher on factors and finding the highest common factor. Please see my YouTube clip Algebra Part 4 for factors and HCF in more detail. So first of all, what are the factors of 12? The factors of 12 are all of the numbers, including 1 and 12, that fit evenly into 12 with no remainders. So they are 1, grab my pen, 1, 2, 3, 4, 6 and 12. So they all fit into 12 and they are the factors of 12. So if we find the highest common factor of 21 and 35, the first thing you need to do is to list the factors of 21 and list the factors of 35. So the factors of 21, all of the numbers that fit evenly into 21 are 1, 3, 7 and 21. And all of the numbers that fit evenly into 35 are 1, 5, 7, 35. And then you look in both lists to find the highest number that appears in both of them, and you can see that is 7. So 7 appears in 21 and in 35. It's the highest number to appear in both. Therefore, the highest common factor of 21 and 35 is 7. So now I'll go through some examples of factorising algebraic expressions. The first example is 4a, add 8. Grab a pen. The first thing you need to do is find the highest common factor of 4 and 8. So factors of 4 are 1, 2 and 4, and factors of 8 are 1, 2, 4 and 8. You can see the highest number in both lists is 4. So 4 is the highest common factor, and that's what you need to start with. So you write the 4 and then you open the brackets. So you look at 4a and you say 4, this 4 here, multiplied by what will give you 4a? Well, 4 multiplied by a will give you 4a, so you open and start the brackets with a. And then you'd say 4 multiplied by what will give you 8? Well, 4 times 2 is 8. So you write the 2 there and close the brackets. Now, this sign in the middle, you've got a positive 4 and a positive 8. So 2 positives together means that this will also be a positive. So 4 open brackets a, add 2, close brackets is 4a, add 8 factorised. Now, the way that you can check that you've done that correctly is by expanding it out again. So 4 multiplied by a is 4a, and 4 or positive 4 multiplied by positive 2 is positive 8. So in the next example, we've got 5a subtract 20b. So we're just going to look at the highest common factor of 5 and 20. Grab a pen. Factors of 5, it's a prime number, so it's just 1 and 5. And factors of 20 are 1, 2, 4, 5, 10 and 20. So you can see the highest number in both lists is 5. Therefore, you'd start your factorising process with 5 and open the brackets. Now we look at this bit. 5 multiplied by what will give you 5a? Well, that will be a. 5 multiplied by a will be 5a. And then 5 multiplied with what will give you 20? Well, 5 multiplied by 4 will give you 20. Then you need to look at the fact that this 5 is a positive, and this subtract sign means the 20 is a negative. So it's a positive and a negative. So when the signs are mixed, then it should be a negative. Now we've also got b. So it would actually be 4b. We can't factorise a and b for this particular example because there would be no common factor between the two of them. They are unlike terms. I'm just going to prove that one by expanding it out again. 5 multiplied by a is 5a, so that bit's right. And 5 multiplied by negative 4b would be negative 20b. So we know that that's right too. So in this next example, 3a add 15b, we have to find the highest common factor of 3 and 15. But you should also notice that there is another common factor there. So when you're factorising, you have to look and see whether there are any common factors with the pronumerals or variables too. And in this case, we've got an a with the 3a and an a with the 15ab. So that becomes part of our factorising process too. So first of all, let's find factors of 3, 1 and 3. Factors of 15 are 1, 3, 5 and 15. So you can see the highest common factor is 3. So we'll start the factorising process by writing 3. Now we need to take out this a and this a. That is a common factor and it needs to go with the 3. Then you open the brackets and you say 3a multiplied by what will give me this 3a? Well, the answer is 1. 1 times 3a is 3a. Then this 15 here, you would say 3 multiplied by what will give me 15? Well, 3 times 5 is 15. And then you can see this is a positive 3 and a positive 15. So that becomes an addition sign. And you can see you've still got this b here. It wasn't part of the common factor process, so you still need to include it here, and then you close the brackets. Let's have a look at that expanded. So 3a multiplied by 1 is 3a. Then you've got 3 multiplied by 5, which is 15, and a multiplied by b. And then you've got the addition sign there because you're multiplying positive with a positive. Okay, moving on to the last one, you've got 18a squared subtract 27a. First of all, let's just find the highest common factor of 18 and 27. So factors of 18 are 1, 2, 3, 6, 9, 18. And factors of 27 are 1, 3, 9, 27. So you can see that the highest common factor is 9. So we start the factorising process by writing the 9. Now we're looking at other common factors. So you've got an a squared here and an a here. So if I just expand up here, a squared is a multiplied by a. So we can couple up one of those a's with the a on the other side here. That takes that squared out, leaving you with just one a there, just like we've got one a left here. So a squared becomes a on its own because we've taken out a common factor of one of the a's here from the a squared plus the other a on this side. And that then becomes 9a. Then we open the brackets and we say 9 multiplied by what will give us this 18 here. Well, 9 multiplied by 2 is 18, but we also need to make it a squared. So a multiplied by a will give us the a squared. And then we have 9 multiplied by what will give us 27. Well, 3 9s are 27. Then we have a positive 9 here and a negative here. So it will be a negative here. because positive and negative equals negative. I've done this on my other clip, so positive equals a positive and a negative equal a positive and a negative equal a negative, and a negative and a positive equal a negative. Now we've still got this A here. Do we need to include it? No, we don't. We took it out and it will still appear in the answer because it's there, and I'll show you that when we come to expand again. So that is factorising. Now let's expand it again. So 9a multiplied by 2a. I'm just going to write that here. That's the first step in expanding. Now you might want to watch Algebra Part 3, where I go through multiplying algebraic expressions. But basically you do the numbers first. So it's 9 multiplied by 2 is 18. And a multiplied by a is a squared. Then you've got 9 multiplied by 3, which is 27. You've got a positive 9 and a negative 3. So when the signs are mixed, like it shows you up here, it will be a negative, or here, positive and negative. And then, because we've multiplied 9a by the 3, you have to put the a back in. So we multiplied the 9 first, and then we have to multiply it by the a to put the a back in, to give you 18a squared subtract 27a. So today we looked at what it means to factorise. We briefly touched upon factors, and then we used that to find the highest common factor, and then I went through some examples of how to factorise expressions. Thank you for watching The Magic of Mathematics with Mrs. Arnold Harsley. Until next time, see ya.